Rainer, and this week we're going to be doing a problem with a book that's pushed up against a wall. So we've got this wall right here, and we've got a book of mass m, and it's being pushed by a force F at this angle theta. And we know all of these different things, and we're told that the book is being held at rest up against the wall. And our job is going to be to find the friction force on the book. So the first thing I think about is whether it's static or kinetic. But since we're told that everything is sitting still at rest, nothing is slipping, I know it has to be static. So what we're going to do is, let's first draw a free body diagram, which I've already done. So the system in this is going to be the book. We're going to have, I've forgotten one force. We've got a wave force pulling down, we've got a friction force, and we don't know quite which way it's pushing because there's also this force pushing up. So it might be holding it down or up in place. But then we've also got a normal force from the wall on the book. Notice the normal force points in the horizontal direction because the surface is vertical and it's always normal to the surface of these things that are touching, whereas the friction is always parallel to the surface that they're touching at. So if we're going to do this, we're going to find this friction force. So my first thought is, the friction force is in the y direction, let's sum our forces in the y direction. So if we sum our forces in the y, right here we've chosen to call y the positive and the upward direction. If we sum them in the y direction, we get static friction from the wall on the book, plus, if I want the y component of this force, I want to use sine theta in this case. So I'm going to say plus F sine theta, F from y on B. And remember, we've just guessed that it's going upwards. So the sign at the end is really going to tell us the answer. And then we've got the weight force pulling down. So I'm going to put a minus mg, because we know it has mass m. And those all have to sum up to mass times acceleration in the y. Since it's held at rest, we know that's 0. So in the end, what we're going to get is that the static friction force is just equal to the weight minus the y component of the force coming in. Now notice one thing. If this turns out to be a positive number, when we plug in these numbers, then the friction force is indeed pointing upwards. We guessed it correctly. If we get a negative answer, all that tells us is that it's got that same magnitude and it's pointing downwards. So that'll be our answer.